Computer vision can also be used for satellite imagery. In this video here, we're going to talk about a bunch of different use cases. We're going to talk about different types of satellite images and so on as well. We have different types of satellites out there. You can get like it zoomed up for agriculture, like parking management, could be monitoring of different systems and so on, but also just how is Earth transforming, how is it changing over time. So computer vision, object detection, segmentation, and all these models here can actually be used on satellite images as well. So when we're talking about satellite images, we're talking about satellites out in space, orbiting around Earth and so on. There's different types of satellites that we're going to cover and so on as well, but the main idea behind like satellite imaging is basically just to get like a very large field of view. Some of these, they can be very high resolution. You can actually like zoom in a lot and get a lot of detail and so on as well. So you can detect like different areas. It can be used for construction, so if you want to build like out a whole construction site, if you have agriculture, if you have like specific cities and so on, it can also be used for that. So computer vision can be used to analyze satellite images as well. So we basically just have this very nice drawing here. We have satellites, reflected solar radiation from the sun and so on that will reflect on buildings, road, grass, forest and so on. And then we also have transmissions back and forth here from Earth up to space where we have all the satellites. Then we just have our computer processing all the images that is coming from the satellite, and then we can see we have these applications we can build on top of it for satellite imagery. So some of the most common types of satellite images is like optical imaging. We already know that, where we have like different wavelengths and so on again, but this is near infrared wavelengths. So this is what the human eye can see. So just normal images as you're used to when we just have an RGB image. We want to do object detection, segmentation, and so on. We also have radar imagery, so that is called SAR, which is basically just for like radio waves we can send back and forth and so on. Here we can capture very high resolution images, detail and so on. So there could be some use cases where that is beneficial. We can also have thermal imaging, where we basically just have these thermal sensors that can go in and detect when heat is emitted from the Earth's surface. Could be different types of stuff going on Earth, but it could also just be the surface itself. So it could be like track forest fires, like monitor geothermal activities and so on, geysers, but again, wildfires and all that is a really cool use case for thermal imaging for satellites as well, because we can cover a large area depending on the satellite and so on that we're going to take a look at, because there's two different satellites depending on the use case. And we also have hyperspectral imaging, which is basically just hundreds of narrow spectral bands that we will then get detections or a value inside. So the human eye can actually only see a very small wavelength or like a range of waves, where if we do hyperspectral, we have a much broader spectrum of wavelengths that we can go in and detect. We can go in and do a lot more details from that. So that could even be like stuff we can't see, like quality control and so on, surfaces and so on, where we can't see it with the human eye, or in the optical imaging, we will be able to see changes and differences in hyperspectral imaging. So I'll talk about different types of satellites out there in space and orbit. So the first type here is basically just satellites in geostationary orbit. So that basically just means that it is geostationary. It rotates around the Earth with the same rotation as Earth as well. So that basically just means that it's going to cover the exact same location, no matter how Earth is rotating and so on. So again, it's just rotating in the same pattern. Then the satellite in the geostationary is just going to rotate in the exact same pattern with the exact same speed and everything. So we can just have like a fixed camera view, even though Earth is rotating around. Then we also have this satellite here in polar orbit, which is basically just a fixed satellite. So it's actually just stationary out there. It's not moving around as the geostationary. So again, this will just be like when Earth is rotating, we will actually be able to see all of Earth while it's rotating, because our camera will be static out in orbit. So these are two different types of satellites that we have for imaging, and again, they have different use cases. If you want to just like do monitoring of wildfires, it might be good to have this one that just rotates around, or not rotates around but static, and then the Earth rotates around, so we cover the whole Earth, or like the whole surface, or like at least in a specific region. Could be that we want to monitor some specific areas, could be like climate change and all that, could be like melting ice that we want to detect with a camera. Here we want a geostationary camera so we can track it over time. So when we're talking about satellite imaging, again, we still have the same models, we still have the same pipeline and so on that we can use. Maybe we can go and use Saatchi depending on how resolution we have, how small objects and so on. Often when we have satellite images, it is very small object. So again, we want to do some real world mapping often, like identify landmarks in the real world. Could be like we want to detect specific things, then we want to map that into real world coordinates. Could also just be like correcting distortion on images and so on. So all the traditional methods, like we have the pre-processing, noise reduction, data calibration, and all that also works for satellite imaging. So we can use image segmentation, object detection, change detection, so we can actually just monitor how are things changing over time. I already covered that a bit. And then we also have image classification if we just want to classify like the whole image, detect different patterns, categorize different land types into different categories and so on. So these are some of the applications. So the best applications for satellite images and also the most impactful is monitoring environmental changes with sample satellite imaging. We can do a lot of stuff, deforestation, global warming, air and water quality monitoring and so on, but also just in specific areas. So environmental changes is a really good use case and application of satellite images. Both where we have this satellite camera moving around Earth, but also just this static one could be used in both cases. We also have this enhancing disaster management with satellite imaging and also computer vision. So here we can see some different stuff that we're detecting in the image. Could be before and after image. It could also be that we want to lay out like a construction site or whatever, do some city planning, infrastructure and all that. It's also a very good use case that we're going to talk about in a second. But here we can basically just see before and after images. Could be before a flooding and also after flooding. We want to detect the changes and also like how much impact did it cause. Next one here is basically just for urban planning and also infrastructure as I covered. If you want to lay out some construction, infrastructure like road system and so on, this is a really good use case. We have a pretty nice light outline here. We have the raw data. We have the step one, smaller images contains farm crop to be outlined. And then we outline them. Could be a segmentation model where we just want to segment out each of these farm plots, and then we can go and classify what each of these individual plots are. So these are some of the main applications that we can use satellite imaging for. We both went over what is satellite imaging, what can it be used for, and also the different types of cameras out there in space rotating around Earth, or we have this static camera. So this is basically just an image. We have different types of images that we also covered as well, but at the end of the day, we will still be able to use the models from Ultralytics, object detection, segmentation, probably not post estimation, but the other use cases are some pretty awesome ones. Definitely test it out. Like there are some satellite data sets, images and so on available out there. Could maybe combine it with Saatchi. You can do track zone, you can have specific regions, optic counting and so on. So try to apply some of those solutions from Ultralytics directly on satellite images. Hope to see you guys in one of the upcoming ones. Until then, happy learning.